Okay, so this mechanism is a booger, but it's a good one to practice. It's a real good one to practice. So the basic reaction goes like this: BH3, and it'll probably emphasize that you've got some non-protic or aprotic solvent, right? BH3 in that, and a second step following hydroxide, peroxide, and water. Okay, and that's going to give you something that you couldn't have gotten by simple addition with water. Okay, so that's the reaction, and the mechanism then, this is the reaction, right? And the mechanism now, you really should pause the video frequently and guess what I'm going to say next. Alright, so the mechanism goes like this. First of all, BH3. Okay, pause the video and say something about BH3. When did we see BH3 in Gen Chem? We saw that in octet exceptions. So it turns out this guy's trigonoplanar. I didn't draw it like that because I want to come in and hit it. It's trigonoplanar, and it's an octet exception for reasons which I think I'll leave out of this video, but it'd be a good thing for you to think about. Why is that an octet exception? But it does make it a super electrophile because it's trigonoplanar and sort of got a nucleus hanging out in the breeze, right? So what happens is this guy comes and hits that, like all of our electrophilic addition reactions do, right? And then in turn, this guy goes there. And this probably should be memorized. That makes sense. That probably needs to be memorized. I mean, this makes sense too, but that's something you can predict just based upon its shape. Alright, so the first thing we get is BH2, right? And you can see already that it's the basis of that. So essentially, effectively what we have, the sum reaction is a hydroxide is going to come in and displace that, and that's not a big deal. Something you may have predicted just by looking at that, but it is a little more circuitous than that. So let's look what happens with a hydroxide and peroxide, a basic solution of peroxide. We're going to have some species that looks like this. Okay. And this is going to come in and hit that boron, because again, this is trigonoplanar and vulnerable to electrophilic, nucleophilic attack. Alright, so we get that. Right? Is that what you predicted from that? Okay. Then the next thing we get is that. Alright, so this is almost like a nucleophilic substitution, right? I got to slow down here when I get to this point. I'm going to draw everything like I had it. 1, 2, 3. 1, 2, 3. And this is going to an oxygen now, which is this guy right here, which I'm going to call number 4. And that oxygen, right? Okay. And that's it. Alright, plus a hydroxide, of course. Okay, so what happens now is this guy comes in and takes that, yeah, he hits that, and this guy goes there. Alright, then the last thing is you've got a water molecule, and this guy comes in and hits that. Boom. Okay, and that's the reaction. That's the full mechanism. Alright, I'm not going to say much about that. That's, as I said from the beginning, that's a bit of a booger. So that goes like that. Alright, and that's one I think you're going to want to go through again and hit the pause button and predict what comes next. Good luck.